Hello everyone. In this video, we look into how can we interpret the data or diagram that are given to us from what is happening during the interference process. Okay. So first, we must know what are the effects of interference to the characteristic of wave. So what will happen to the wave itself after or during the process of interference. So first, we will look into the wavelength. Okay, the wavelength. So what will happen to the wavelength of both wave? Okay, remember we have two wave, coming from two coherent sources. So what will happen to the wavelength? So the wavelength of both wave will be unchanged. So there will be no change in the wavelength. Next, what will happen to the frequency? Okay, for the coherent sources, the frequency must be equal. So what will happen to the frequency of both wave during the interference? So again, frequency also become unchanged. Okay, wavelength, frequency, and the last one is the speed of the wave itself. Okay, speed of the wave itself. So we have three. Okay, we have wavelength, frequency, and speed. So all of them are not disturbed by the event, by the phenomena of interference. Okay, it is unchanged or equal. So unchanged. Okay, after or before, the wavelength, frequency, and the speed are the same. Okay, so what is changed during the interference? So let's look into the amplitude. Okay, so amplitude, it can become either amplitude. Remember we had discussed about this one. So amplitude will become either zero, okay, being completely distracted, or it can also become maximum, or twice. Okay, twice. Okay, normally it is twice lah. Okay, so either zero or become twice. Okay, zero at node point where the uh, destructive interference happen or occur, and max point at antinode point where the constructive interference occur. Okay, so this is what will happen to the amplitude of both wave. And then the wave pattern. Okay, wave pattern. We look into the wave pattern. So what will happen if we have two wave? Okay, let's say two water wave. Okay, so calm water and strong wave alternately. Okay, we will have calm and strong wave alternately. Okay, maybe strong and then calm, and then strong and then calm. So this is what we call as calm and strong wave alternately. This is happen to the water wave. Okay, what will happen to other wave? Okay, we have a lot of different wave. So this is water wave, and then we had also looked at the light wave. Okay, light wave. So for the water wave, it is clearly, okay, we can see clearly how the wave being changed, how the amplitude of wave being changed. Okay, calm and strong wave. Okay, the strong will produce larger amplitude. Okay, you can see this one, we can observe this one on the sea or on the river. Okay, surface of sea, river. But this one for light wave, okay, it is quite hard to observe this one. Okay, normally we need to do a simple experiment in our lab. So for light wave, if we have interference occurred around us, what can be observed is there is a dark fringe. Okay, dark fringe. So dark fringe and bright fringe alternately. So let's say we have two sources of light. Okay, two sources of light, and then we try to project both of them on the wall or screen. Okay, and then what will be produced on the screen or on the wall, there should be a bright and dark fringe. Okay, bright and dark fringe. So let's say this is dark, bright, dark, bright, dark, bright, dark, bright, dark, and continuously. Okay, so this will be this can be observed in our lab or in any uh, phenomena, okay, any phenomena that involve interference of light wave. This one, water wave, can observe clearly from the sea, okay, and this one we need to do simple experiment in our lab, or maybe sometimes you can also detect this phenomena, okay, around us, okay, due to some of the light sources coming from different type of light sources. And the next one, okay, for water wave, light wave, and the last one we look into the sound wave. Okay, so what will be produced when we have interference of sound wave? Okay, we have sound wave. So for sound wave, it is not hard to detect the interference produced by the sound wave. Okay, since the wavelength is quite large. So let's say we have two speakers or any other sources of sound. Okay, so we have two speakers produce wave, and there will be interference between the two wave. So what can be observed or what can be detected when we have this phenomena occurred around us? Okay, we will have a loud sound and weak sound alternately. So let's say you are here and you are walking in this direction. So what can be detected there? Okay. Okay. Let's say at this point, maybe you detect weak sound, and then loud, and then weak, loud, weak, loud, weak, loud, weak, loud, and so on. Okay. Alternately. Okay. The weak sound and loud sound will be alternately according to their order. So if you walk in this direction, just like what happened to the light wave, they produce bright, dark, bright, dark, bright, dark. Okay, in this direction. But for sound wave, it will produce loud, weak, and loud, weak. Okay, so that is happening during the interference process. Okay, and then we try to look at a simple diagram how we can interpret, okay, this diagram to relate it to the interference of wave. Okay, here we have example 2. Diagram 2 shows the interference pattern produced by two sources of P and Q. So we have sources P, okay, this one P, and this one is Q. Okay, so the solid line here represent the crest. So here we have solid. So this is crest. This is crest. This is okay. This is crest for P. Crest for P. This one also crest for P. P is the center. Okay, if you look carefully, okay, let me try to draw it. Okay, so we have source P. So we produce wave in all directions. So we have crest for P, and then another crest for P. Okay. And then the dotted line will represent the trough. Okay, the trough. Okay, this one, if we look the wave or if we observe the wave from the uh, plan objective or from the upside of the wave. Okay, just imagine you are on a certain height or certain building, and then you observe uh, towards the source, and this is the crest, and then the dotted line will represent the trough. Okay, so trough, trough, trough. Okay, if you observe from the side of the wave, maybe you can see okay, here we have trough, crest, trough, crest, trough, crest, trough, crest. So the solid line only represent this one, the crest, while the dotted line represent the trough. Okay, for Q, okay, for Q, so let's say we have another week for Q. So we have crest, and then crest, and then crest, and trough, dotted line, trough, dotted line, and then trough, dotted line. Okay, this is just the wavefront of the wave from above. Okay, what can be observed from the above of the sources. Okay, that's how you can interpret the diagram. So analyze the interference pattern of water wave based on the following instruction. Okay, let's try to follow the step, okay, that being instructed to us. So mark with a cross X in diagram 2 at the point where the crest coincide crest. So crest meeting crest. So where is the point crest meet crest? So crest and crest is where the, okay, remember crest is the, sorry, we try to change to another color. Okay, so crest, where the, so where is crest? Crest is the solid line, solid line. So we have two different solid line, okay, the pink one and the yellow one. So pink will meet the yellow one, so we cross X. Okay, here X, and then here X. Okay, this one we do it in our my diagram. If we try to do it in the diagram given here, so we have X, okay, crest meeting crest, and then where is another X? So here solid meeting solid line X, solid X, this one solid, okay, this one solid, and then this one solid and solid, right? And so we have solid, solid, sorry, this one solid and dotted, this one solid, okay, and this one solid, this one solid and dotted. So this is not the cross. You have other cross? I think that's all. Okay, so that is where the crest coincide crest. Mark with star at the points where trough coincide trough. Okay, oh sorry, I just mixed the, is it right? Okay, right. So we had done correctly. So let's try to mark trough coincide with trough. So star, what is trough? Trough is the dotted line. So here we have dotted, mid dotted, star, and then dotted, dotted, star, and then this one dotted, dotted, star, dotted, dotted, star, dotted, dotted, star. So here dotted, dotted, star, this one dotted, dotted, star. Okay, so here dotted, dotted, star, and then we have star here, around here, maybe here. Here is also star. And this one we have star, and here star. So do we have other star? Okay, I think that's all for star. Okay, next, the point X and star is called as where at this point. So what is X and star? Okay, X crest meeting crest, right? So let's just write it here. So X crest meet crest, and star is trough meet another trough coming from other sources. So let's refer back to our discussion before. Okay, we had discussed about what will happen crest, mid crest, trough, mid trough, and crest, mid trough. Okay, so if we have crest, mid crest, trough, mid trough, what will happen here? Okay, they will produce what we call as constructive interference. Okay, constructive. Okay, let's recall back crest meeting crest. It will produce constructive interference, or trough meeting another trough, it will produce constructive interference, but okay, on the other side of the equilibrium line. So here is the constructive interference, where the point we call it as antinode. Okay, so here we have, it's called as antinode. Okay, the name of the point. So antinode. So point where at this point, the total displacement is, okay, remember what will happen to the total displacement? Normally it become twice or maximum. Okay, we can put it as twice or maximum, become maximum point. Okay, the highest, okay, the highest possible point that we can get, okay, from the two waves. So at the points, what will happen, what type of interference? It is what we call as constructive interference. Okay, okay, now let's mark with a circle at the point where a crest coincides with trough. Okay, now let's look back at our diagram here. So what we want here is circle where the dotted line meet the solid line. So here we have one. Okay, why it is not changed to the color? Okay, okay, here one, and then here solid dotted, solid dotted, solid dotted. Where else? So here we have solid dotted, solid dotted, and then solid dotted, solid dotted, solid dotted here. Okay, and then where else? Solid dotted here. Okay, and then here we have solid dotted. Okay, solid dotted, and so on. Okay, so we have marked them with circle. So the point circle is called as, so what is the name of this point? Remember, when trough meet crest, what will happen? It will destruct. Okay, it will come zero amplitude. So this point we call it as a node point. Okay, node point, where at this point the total displacement is equals to zero or minimum. Okay, at the points, okay, at the points, what type of interference? It is destructive interference. Okay, connect the point X and start to produce several lines. Okay, let's try to connect the lines, sorry, the points. So what will happen? Okay, we will get straight line. So straight line. So here also we have straight line. Here also straight line. Okay. To produce several lines that we call as, so those lines that connected all of the so what is X and star? So X and star is the constructive, so it is antinode. Okay, we connect all of the antinode, so X and star antinodes point to produce several lines, we call as, so these lines, when we connect them, we call it as antinodal line. Okay, just change ES and AL. So antinodes for point, antinodal for the lines connected all of the antinodes, we call it as antinodal line. And if we try to connect the point O or point 0, okay, sorry, this one, the blue one is the point O, So let's try to get our antinode first. So this is X antinode. This one antinode. And this one antinode. So become antinodal line. This one is antinodal line. Okay, so the blue one here is what we call as, okay, it is the line connecting all of the nodes. So we call it as nodal line. Okay, we call it as nodal line. Okay, nodal lines. So draw a straight line parallel to sources. We call the lines as, so parallel sources. So this one. Measure the distance between the two sources. Okay, the distance between the two sources. So here we call as A. Okay, draw a straight line parallel to sources. We call line as what kind of line? Okay, this one. And then we have A. Okay, we have D and we have X. Okay, what is A? For interferent cases, okay, A represent the distance between the two sources. So we have two sources. Let's go back to our sources. So A is the point from the two sources. So this one we call it as A. Okay, A. And then what else do we have? And then we have D, distance between the sources and the detector line. So this is the detector line. Okay, where is the detector line? So it is here. We call it as detector line parallel to the sources. Okay, so you can make the lines anywhere around here, but it must be parallel. So here we have sources. So the detector line, okay, the detector line must be, okay, let's try to get the color. So it must be parallel. So let's say it is here. Okay, so here we call it as the detector line. Okay, it is parallel with the line between the two sources. So we have detector line, and D, capital D here is used to measure the distance from the sources and the detector line. So D from the sources, okay, from the sources. So from here, this is the sources to the detector line. So this is what we call as D. Okay, if your line drawn is here, so your D should be from here to here. If you just draw your detector line here, so your detector line here should be from the sources to this position. Okay, remember the detector line must be parallel. Okay, same plane. And what else? Okay, then we have X, we have A, D, and the last one is X. Okay, those are the variables that we need to know when we try to solve problems of interference. So X is the distance between two successive nodal line. Okay, if we have nodal line, so where is the nodal line? Nodal line. So we have nodal line, okay, a lot of nodal line. But where we want to measure the X, so X must be taken on your detector line. Okay. So let's say this is your detector line. Okay, on the green one. Okay. So let's say where is node? Node is this one. Okay. No, the blue one. Okay. If you try to extend, it will meet the green one on this one. And then the blue one here. And then the extend blue one will meet green one here. And then if you try to extend the green one, so the blue one extend and then it will meet here. Okay. So N is measured from this position. X. So this one is X. Okay. So in the diagram, maybe you can see the distance, maybe difference. Sorry, it is not here. There is no point here, just here. Okay, X. And is it here? No, this one is wrong. Okay, this one is correct. So here is done. The last one is here X. So we have 3X. Okay, 3X. So the line should be at equal distance. Okay, the length of the line, since it is X, so it should be equal distance. But the diagram is not quite right. So the distance, what you can observe here is not the same. But if you try to draw it correctly, then you will get X are equals. Okay, X are equals. So what else do we need to know? And then we can calculate the value of AX divided by D. Okay, A, distance between the two sources. X, distance between the nodal lines. Or you can also measure the distance between antinodal nodal line. And then D is the distance between sources and the detector line. And then value of this one in cm. Okay, maybe you can try it in your books and measure the wavelength. Okay, wavelength, you can measure. How you want to measure the wavelength? How you want to measure the wavelength? You just take out your ruler and measure from crest to crest or from trough to trough. Okay, if you have a wave, remember how to measure wavelength. Crest to crest is the wavelength, or trough to trough is the wavelength. And then if you compare those that you had measured, okay, if you compare the wavelength and AX over D, you should get lambda is equals to the AX over D. Okay, so this is the formula, the only formula that we use in interference when we want to solve problem involve interference. So lambda is the wavelength of the wave. A, distance between the two sources. X, okay, the one that we want to observe, maybe loud and weak sound, or maybe bright fringe and dark fringe, or maybe the wave, strong wave and weak wave. Okay, depends on the wave that we want to observe. And then D is the distance between the sources and the point where we want to detect the difference of fringe, loud or wave. Okay, so that is how we can interpret, or we can try to understand the problems involving interference. Okay, later on we will look into the relationship between them and how to solve a few problems involved in interference. So I think that's all for this video, and see you in our next video. Thank you.